Hi everyone, it's a wonderful sunny weather today in Krakow, and unfortunately you are not enjoying the sunny weather. You're sitting in here, for which I am very grateful to you. Thanks for coming in here. I hope it won't be time wasted. This talk is about Nix. Nix is a package manager, as you can imagine from the title of this presentation. How many of you have heard of Nix before? Oh. How many of you are using Nix? Okay, that's a bit better. Because this, no, let me get this straight. This talk won't be about hacking Nix for fun and profit. It won't be about, advanced use cases of Nix. What I'm trying to convey here is that I've discovered Nix some time ago. I've started my adventure with Nix, and I think it's pretty great. So I wanted to share what I've learned so far. It's basic stuff, so if you know it, you can probably leave right now. I don't think you'll find anything interesting in here. But if you stay, I'll tell you what I know about it and why I think it's worth your attention. So my name is Piotr Gaczkowski. And I'm an imposter here, actually, because this is a conference on functional programming and emerging technologies. I know next to nothing about functional programming, sad to say. I mostly work with Python, and the closest I get to functional programming is using lambdas and MapReduce in Python. So that's that, sorry about it. Although I had a small experience with Elixir on HackerRank, I wrote a few challenges on HackerRank, send them to my friend who uses Elixir daily and ask him for his feedback. At first he said like, oh yeah, that's the nice use case for pipelines. Then he saw the rest of my code and he never spoke to me again about Elixir, so I guess he's jealous. So that's that. As you probably know, package management is hard. How hard is it? Well, it depends on which package manager do you use and how many of them you have to use at any given time. So which package managers do you use daily? Okay, NPM is one fine example. Hex, yeah. Brew, that's one of my favorites, yeah, definitely. Peep, Pacman, yeah, a lot of them. What's interesting is that some of them are more architected toward package managements for libraries, for generally stuff that touches one particular language. For example, pip is definitely for Python, right? I won't imagine using pip to install, for example, I don't know, a web browser. Though I've seen some NPM packages bundling, for example, Chromium binaries, which I consider interesting. You're free to do so, but it's not really what this package manager is for. On the other hand, we have the system package managers, right? Like Brew, for example, like the Pacman, like the known and loved APT or RPM, right? So these are the package managers that can install you, I don't know, a DNS server, an Nginx server, whatever else you require that is a system dependency. But they can also install some Python packages, for example, or other language-related packages. So at this point, we are getting a bit schizophrenical. We have one package manager that can install us, for example, a library that we require for our own piece of software written in Python, Elixir, or whatever. And then again, we have these languages can do the same thing. Which one should we use? Which one is, I don't know, better, more secure, more up-to-date? Okay, more up-to-date, that's easy. Usually the one that is not tied to the operating system is more up-to-date. But all the other questions, it's not that easy. So nowadays, when we think of package managers, we can see the aforementioned apt-get, the RPM, the homebrew, the pip, gem, npm cable, all of them. But also we have Docker used as a package manager at some points. For example, if we want to install something without actually going into all the details of installing all the dependencies, stuff like that, we can just download a container image, run it, and it's all perfect and splendid. Then if we venture forth into the realm of cloud native, we have, for example, Helm package manager, which is a package manager used for Kubernetes. There's a lot of this stuff. And what we want from package managers, we as users, is basically what you see here on the slide. So we want the package managers to neatly and tightly pack all the things that we need and give them as gifts, basically, so we can use it. Well, how it looks like in real life? More like this. We have lots of different stuff that sorta, kinda, we can stack together, but yeah, it's very far from being elegant. So, how the Nix is different? Nix is different in several ways. First of all, when we say Nix, we can mean several different things. Because one of the definitions is that Nix is a domain-specific, purely functional, lazily evaluated language. That's true for the Nix language, because there is a Nix language, which is a general purpose programming language that is, yeah, functional, lazily evaluated. That's easy. But there's also Nix, the software. The software which acts basically as a CLI that lets us install different packages, different software, or execute programs also as a kind of side effect. So yeah, this language is mostly used for describing packages and their dependencies, how to build them, how to make everything work together, which isn't something that's common for programming languages. I think most other package managers don't use actual programming languages. They most probably use some domain-specific languages to achieve the same thing. There's also, of course, the package repository for Nix, which is called Nix packages. That's also something understandable, because if you want packages, you have to store them somewhere. You have to store all the definitions in some place. Nix packages is quite similar to Homebrew, which we've already mentioned, in that it is, at this moment at least, hosted on GitHub, and basically everyone is free to contribute. You can open a pull request to update a package. Then the package's maintainer says, yeah, it's okay, let's merge it, and your package is ready. It also uses Git branches to keep track of the stable releases versus the bleeding edge, because sometimes we want things stable, sometimes we want them definitely less than stable. Depends on how adventurous we feel at the moment. And the final piece of the puzzle is the Nix OS, which is a Linux-based operating system that uses Nix as the main and only package manager. Not only the package manager, but also the configuration manager, because basically you can write a program in a functional language that produces an operating system pre-configured for you with all the necessary daemons running as you please, with the configuration, with everything. So it's really interesting in that way. So some of the cool features, a friend of mine hates me for bringing bullet points to my presentations, but I can't help it. Some of the cool Nix features that I see are that it operates in userland. So basically, there's a one-time step that you need to run it with super user privileges just to generate the /nix top-level directory, and then everything else is operated in userland. Each user can install own packages, have their own environment. Homebrew does something pretty similar. Homebrew on Linux also has something pretty similar, but in Homebrew on Linux, we have all the user packages stored in the same place. We can configure it to be somewhere else, but we lose some of the advantages this way. In Nix, basically, after this one-time installation, each user can install whatever they want. Second thing, packages and environments are deterministic because we operate on closures, we operate on hashes of everything that we install, and each installation doesn't just unpack stuff into our file system. We basically have generations, so we can do atomic upgrades and also atomic rollbacks. If we install something and we decide, oh no, it just doesn't work well with some other package we have, we can roll back and it's like we've never installed this thing. Everything is exactly like before. So there's virtually no chance of us destroying our operating system by accident, which happened to me often when I was running Debian and switched to experimental branch because I wanted fresh software. So yeah, that was pretty hard. Then we have built environment management. So instead of just installing all the packages to our own profile, we can also define in a given project that this project requires these specific packages with these configuration flags, and we also need to, for example, install some additional Python packages from pip to accommodate everything. And we can have this entire built environment managed in a single file or a set of files that reside in our directory. So whenever anybody from our team or, I don't know, open source contributors to our project download our project, they can basically start hacking right away because they need to just enter a Nix shell, which will install all the dependencies, and everything is not only there, but also configured in a way that we want it, because it's really not we can't just say to our users that, okay, you need to have, I don't know, Node.js installed to run this application, because Node.js comes in so many different versions that some of them will work, some of them won't work, right? We can say that, okay, this works on Node, I don't know, whatever version, 7 like. But then again, Node 7 can be configured in a different way, whether it's installed from an auto-installer, whether it's installed from one package manager or the other. There would be slight differences between each of them. Most of the time, they'll be harmless, but if we want to have really deterministic development environment, Nix can achieve it. By the way, this is also something that Docker promised us, and in many cases Nix is quite similar to what Docker does. Most of the things that Docker does, Nix can do, and can do better. It can also produce container images if you want, so that's not an issue. The only problem is that Nix has worse marketing, so it's not as popular, as widespread as Docker. Yeah, it can run multiple versions of packages like I've mentioned, and it runs on Linux and Mac OS. I'm not sure about BSD, but if it runs on BSD, then we have all the major systems covered, so no problem with that. It features functional approach, so installing or upgrading packages, as I said, won't break other packages, won't break the system. Even if we somehow install something that is totally broken in Nix, and we're not running Nix OS, but Nix on a different system, we can just switch back to system packages and get on with it. But we don't have to, because we can always roll back the last upgrade. We can travel back in history to whatever generation, as it is called, we were running previously. So each installation, each modification that we do to our system is stored as a generation. So this way also we won't have an inconsistent state, because installing a package can either result in a success, in which case we have a new generation and we are actually running it, or if it fails, we don't have a new generation and all the stuff just as it was before. So pretty cool. This is an example of a function. I'm not sure if you can see it well. I definitely can, but I can live with that. This is a definition of a Hello World package. So basically, at the beginning, we have name, we have the version, we have the URLs from where to fetch it, and after that, we have the sort of instructions on how to build it. This is pretty similar to what we have in Homebrew. But this time I would say the Homebrew domain-specific language is a bit more, bit easier to understand, I would say. That's my opinion. Maybe you'd prefer this in here. The Homebrew is based on Ruby, of course. This one is a purpose-built programming language, so there's one of the differences between them. So does Nix provide us with those neat and tight gifts of packages that we want? Not exactly. I wouldn't say it's entirely perfect solution. It's closer to this, but still it's pretty cool. At least all the boxes are the same size, have the opening at the same side. We know how to use it if we only learn some basic stuff. So it's a progress, definitely a progress. Where Nix really shines. It's great for multi-user environments. If we want to have a machine, for example, a cloud machine used by several different people to compute some long-running processes, each of them can install their own versions of their own specific packages that they want to have. In data science, for example, that's something that that is really needed, because tiny differences between the same package and different releases basically can deliver enormous differences in, for example, computation time. So if you know that this version runs all your computations in like 3 days, you don't want to run a version that performs the same in a month. So, and this might be different between different workloads. So one user may want one version, the other another one. So back to Nix as a package manager. Here is a list of some of the most popular commands that we can use in Nix. So we have nix-env-i elixir, for example, to install elixir. We have nix-env-e to remove elixir. We have nix-env-u to upgrade elixir. We can list all the installed packages by nix-env-qa, and we can refresh the package repository by nix channel --update. Now, there's a funny thing, because you may start to get the notion that we have several comments here, and these are not all the comments in Nix, unfortunately. There's much, much more. So when I've mentioned that Docker has better marketing, Docker also, at least in my opinion, won hearts of the people because of the simple tool set. You have one Docker command that does everything. You have Docker run, you have Docker build, Docker push. There's one thing that can do everything that you want to do with containers and container images. In Nix, we have different programs for that, which is closer to the Unix way, I would say, but can get a bit confusing after some time. Before some time, when you are just trying to figure out, okay, which command should I use? And yeah, by the way, each of them has different switches. So for example, nix-env-i installs a package, but if we want to run a Nix shell, which I'll present shortly, and install the package in a shell, we would use nix shell-p, not I. So trying to figure out which light switch is which is pretty confusing. We can install remote packages without the need to actually mess with our package repository. So if there's one package at one place, we can install it into our system by using the standard nix-env-i, the name of the package, -f, the location of the archive with the Nix formula for, yeah, I've used formula, too much homebrew, with the Nix description of this package. So that's also pretty cool. If some of you have own packages, for example, on GitHub, and you want to make it easier for users to install them, you can add this little comment, and then if people run Nix, then can install it right away without the need to do several different things that's usually required. For example, if you want to add a new apt repo or anything like that. Nix expressions. Nix expressions. So the Nix language consists of Nix expressions, and they are deterministic, of course, as far as network connectivity goes. So the promise of Docker, for example, was that once you write a Docker file, then you can use this Docker file from now on until the eternity, and it will always produce the same output. But does it really? Not necessarily. For example, if we are using Alpine inside Docker, the Alpine package that we are using may be updated at any given time, so we won't get necessarily the same result. Also, the base package can change, and yeah, there's the case of network connectivity, for example. So if we can't connect to the central server, central repository, then we're basically doomed. In Nix, it's a bit easier because we can, at any given time, fork the entire Nix packages repo. We can modify it if we want it, but we can store all the necessary data to rebuild our environments and have a control over it. So it's better in that way over using some third-party systems. Yeah, I've mentioned the generations. We can list the generations. We can roll back the last change to our system. We can switch generation to some previous one. So for example, we now have Elixir, but we decide we want to go to pre-Elixir times. We can switch to generation, for example, 3. And yeah, we're back to caveman times. And the switch generation also has big G mnemonic, so we can use that as well. Is it interesting? For me it is. I'm dealing a lot with, for example, infrastructure code, like Terraform. And Terraform has its own quirks, like .11 Terraform doesn't like .12 Terraform code. Each time you update the Terraform binary that you use, the state changes and people running different versions, previous versions, can't access it. So it's necessary to have the exact same Terraform version as everyone else is using in this project. But if you are working on several projects, one of them uses .11.6, the other one is using also .11 but .7, switching between them in a standard package manager is not something that's very convenient. With Nix, it's much better. Okay, so Nix has the concept of closures as well. And in Nix, the closures are basically the packages with all of their dependencies. So for example, if we want Firefox, we have the Firefox, the whatever graphical library that it's using, all the SSL libraries, etc., packaged in a single closure. The closures can be copied between different systems. So we can, for example, install and configure Firefox on our own system, and then copy this closure, for example, over SSH to a remote server, and this would work exactly in the same way as it works on our machine. So another cool feature from my perspective if we want to share software or share configurations between different people. Then there's the Nix shell, and the easiest way I can explain it is that it allows you to run whatever package is available in the Nix repository without the need to actually installing it on your own system. So you can write nix-shell-p Elixir, and you're presented with a shell that has Elixir closure, so Elixir with all the dependencies installed in it. When you exit the shell, you no longer have Elixir on your system. Of course, if you're an Elixir developer, this isn't like rocket science because you have Elixir installed. But for example, you want to install something that's potentially mischievous, like, I don't know, Node.js. So you can do this, and after you're finished, nobody will know that you are running Node.js. So your computer is safe, your ego is safe, everything is safe. And also it's great for portable development environments because this way we can make sure everyone on a team is using the same shell, the same packages, the same whatever we need. So if something crashes on one machine, then it should be reproducible on another. Also, if we want to check all the packages that we have installed together with their hashes in our Nix profile, so a directory in our home dir, we have this manifest Nix, which lists everything. This shouldn't be modified. This shouldn't be used verbatim, but it's always nice to see what we have heard so far. So that's the place when we can learn it. And going further with the Nix shell, we can have a direnv. How many of you have heard of direnv? Not many of you. Okay, so direnv basically is a program that hooks into the change directory in a shell. Each time we change directory, it checks whether there is a .env file with some configuration in it. If there is, it executes some commands. So we can, for example, in this way, set all the necessary environment variables that we need for a given project. We can activate virtualenv. We can do whatever we want. Combining the direnv with Nix shell gives us the power to basically change directory to our project directory. We open a new Nix shell with all the necessary dependencies installed, with our entire development environment inside it, and we can just start happy hacking. Basically, it can look like this. This is the most I don't know, straightforward example. So we have this .env.rc file, which is for .env, and it says use Nix. So do whatever is specified in the default .nix file. And then in the default .nix, we say that we want Python, Git, and new make installed in our shell. That's all. Oh, there's one more thing. We want to activate the virtual env after installing all the Nix dependencies. So that's that. There's also Lori, a Nix shell replacement, which claims to be better for project development than Nix shell is. It also hooks to dir-env. I haven't yet explored how and why is it better. The website of the project to me, so I understood only a subset of words, so I decided that I'm better off with just plain Nix at the moment. But if you are already using Nix, this is something that might be interesting for you. And another cool hack, I would call it, is that we can use Nix shell in a standalone scripts as a shebang. So if you're not seeing this very well, in the first line we have a classical Unix shebang that says to run Nix shell, and then we say that we want to have an Elixir available in this shell. We want Elixir installed, and we also want the Elixir binary which will interpret this script. So this is an Elixir script that doesn't require Elixir installed on a system to run. Each time we run the script, it runs first Nix shell, installs Elixir, opens Elixir, interprets the script, finishes. Yeah, and it cleans up. So I like it. Actually, this presentation was inspired by something I saw last year on PyCon-PL. And Asko Soka, I think I didn't botch his name, showed us an example of chaining together several Python scripts together with their different dependencies, generally building an entire big pipeline in Nix that would generate an image of a black hole. For me, it was pretty amazing. I have no idea how it worked, even though I read the code several times. But you can do such things with Nix shell. So you can basically create entire programs, entire pipelines that do not require installation of carefully selected packages in your users' environments. So yeah, that's also big. So how does Nix compare to the rest? This is my personal opinion, of course. I'm a longtime fan of Homebrew, so I think that while Nix presents many great features, it's not, unfortunately, as easy to use as Homebrew. For me, when I saw a Homebrew formula for the first time, I immediately knew what has to be done in order to implement my own formula. In Nix, I'm proficient enough to modify some formulas to upgrade them to newer versions. They don't always work, but I think I'll get more proficient with time. So it's not easy, it's more powerful. Choose your own weapon as you like it. There's also, I'm not sure if it's a fork, not entirely a fork, a clone maybe of Nix, but instead of using entirely new programming language, it uses the new scheme, which is a Lisp dialect. And this package manager and operating system as well is called new Guix. I don't know how to pronounce it, but you see how it's written, so that should be easy to find. Basically the same ideas, the same approach, only using a different language. If you're using a new scheme, if you are, for example, an Emacs user, then this should be pretty familiar for you and maybe more interesting. So if you love parentheses, you'll definitely love this package manager. And yes, it also works with drenv, so you can have the same great development environment in a box approach with that. So here's what I've learned about Nix so far. Thank you for coming here and wanting to hear my journey about it. This is a video of an inspiration of mine that made me do this presentation today. Watch it. It's really much more cool than mine. And thank you very much once again. If you have any questions, you're welcome.
Thank you very much. I'm a pretty big user of ASDF when I'm installing languages or even databases and such in order to be able to switch between them on different projects. It sounds to me like the combination of Nix and drenv is providing more or less a similar environment for me where I can switch into a project directory and let Nix take care of making sure I have the correct version of Python or Elixir or whatever, and I'm using the right version of Postgres. So I'm curious. I don't quite understand how it is that Nix is both an operating system and works on, say, OS X. With drenv as a developer, can you kind of describe to me how that might work? Okay, so I've mentioned Nix as an operating system, but that's Nix OS. So Nix OS is one thing, and you can just run Nix OS as a pure operating system, but Nix, the package manager, works generally everywhere. So you can install it on a Mac, you can install it on a Linux distribution, you can install it on Windows subsystem for Linux, for example. This will work without a problem. So this way, it hooks into drenv, which in turn hooks into the CD. So each time you switch between the two projects, first the drenv would notice that, okay, you've changed the directory. Okay, there's some configuration to be done. It sets all the environment variables, then runs the necessary Nix configuration, which makes sure in turn that you are running the correct versions. So the way it works is that each package is installed into separate prefix. This prefix is basically the hash of the contents of the package. So each version has entirely own prefix. And then we have the classical symbolic link magic with making sure that what you have in your profile is this version and not any other version. So that's the way it works.
Thank you for the presentation. So I have a couple of questions. First one is, so this looks like, I could use just Nix as a build tool, but for the deployment part, does it work with, say, something like Ansible?
That's a good question. I haven't considered that, to be honest. I think I saw somewhere that there is a Nix module for Ansible. So this should be doable this way. But even if there isn't a Nix module for Ansible, I could imagine a scenario when we run Ansible, install Nix on a remote machine, copy a given Nix file with configuration to that machine, and then install everything that's in it. So this should at least be possible. Another way would be to reuse the closures that I've mentioned before. So you create a closure that has everything that you want installed on a given machine, and then just transfer it over SSH to the remote machine and use it. This can also be hooked into Ansible, for example. And the final thing, with Nix, we can also, as I've mentioned, create container images. So you can build your own environment locally, then convert it to a container image, and then deploy this container image with Ansible or whatever other deployment tool that you're using.
So that actually ties into my second question, which was, say I have a monorepo, and they're like sub-projects, but they are all different flavors, say Python, Scala, some JVM based. So like with Nix, how would Nix handle that? So if I'm building an artifact, is it a manifest of all the sub-project dependencies, or it isolates at the project level? Like how do you?
So basically each project can have their own configuration, and you can have some, for example, meta configuration at the top level that imports all those projects inside it. So if you're only working on one project, you would have only the stuff that you want for that project installed. And if you are running, if you want to hack on several of them, you can install everything from the top level directory. And this way, you would have the dependencies for this one, for that one, for another one. If the projects are using different versions, then basically you could achieve this with the direnv, like I've mentioned. So each of them would have a separate direnv with separate Nix configuration. The Nix configuration will pin the packages, and when you change directory from one to another, it will do the switch of symbolic links to allow you to work on what you want.